Hello, my name is Mateo Vasquez, and today I'll be taking you through the wonderful world of IT. Today's topic is
The internet. Yes, the internet. Today's topic is the internet. No, we're not looking at internet browsers, and we are definitely not looking at internet websites, although these are great applications and phenomenal ways to use your time, or waste it, whatever you feel like at the time. We're looking at the physical internet as an entity. The actual connections, bridges, protocols, and everything that creates this giant information highway. Before us here is a map of all the internet connections that currently occur across landlines and their frequency of occurrence, with the US and Canada taking the majority of this. However, Europe does have its fair share, and many different connections all over the place are created through the internet. The internet is built up on a series of communications and data hoppings. It runs through a series of fiber optic cables designed to link together many different parts of the world. Internet users connect to different types of internet networks depending on the type of ISP that they're able to access. The internet then bounces the information from place to place. Example here would be the internet user sends information to the Tier 3 network, the multi-hand ISP, which then connects to a Tier 2 network. The Tier 2 network is another ISP that connects to the Internet, the Tier 1 network. From the Internet, the information is requested and sent back down either through the Tier 2 ISP or through the Tier 2 network. It continues to spread across different routes until it returns back to the user, usually following a similar path. So what's more likely is it goes up here to the internet, back through the Tier 2 ISP, to the Tier 3 network, back to the internet user, sending information through several hops and across all different kinds of places. If you request an internet page from, say, Mozambique, you'll connect to an ISP there, which will connect you to a city, which will then connect you to the physical Africa landline cable, which connects you to Europe, which connects you to the Spain cable, which will bring you down to the home site of the actual location where the file is stored. This type of bouncing is known as data routing. Here's another diagram to represent how this basic function works. The local ISPs form little chains, with each single one of them representing another house. One of these would represent one of the houses around here, connected to a network over here. These networks and chains all put together will connect to a stronger ISP that is able to actually get to the transit, where it is sent and shipped across all different types of internet mainframes and stations until it reaches its intended destination, say here. After several hops, it's been found. Now this is actually traceable using the tracert command on internet functions. However, to use this, you need to enter the command prompt and enter tracert. This allows you to actually track how your internet ISP is going between things and is used for correcting data bugging and problems of natures where stuff is simply. This map represents the physical fiber optic cables that actually run and span the entire internet. The internet is based off fiber optic cables. Information travels through these from different areas. These are the major cables, and as you see, they link together many different areas. Now, certain areas do have more cables than others. A great example is the United States linking with Europe has probably the highest condensation of cables, followed by the United States to the Asian coast. However, places like Africa have a generally smaller connection of cables, such as the South Africa to the Indian Ocean, and Australia usually doesn't do so well either. However, the internet basically sends all the information through these cables, which is why sometimes it does take a while for the internet to have anything occur, and why some places simply do not have internet without doing wireless satellite communication. Also, the size of these cables restricts bandwidth and how much information and data is able to travel across each one of these. This map also represents the data traveling between different fiber optic cables. However, this one also shows the global traffic, 2012. Larger areas represent far more traffic where actual communication is occurring. Again, The United States and Europe is probably one of the largest, and the internal country maps are not shown. There's a five chain. It kind of forms a skewed parallelogram in the United States that connects sort of like this. And that also has a ton of communication through it. Again, it's a giant overlay over each country, and several countries have this. Some don't have as strong internet connections, such as over here. However, the traffic is based around flow between continents at this time. This is how it's represented for 2010. Now, the internet works under HTTP codes and protocols, hypertext transfer protocol. This is how the internet is able to communicate between all different types of sources and networks and pages and able to send data across each other. It tells what's sent where. These are some common HTTP codes that are found. Some of them may be familiar, some of them may be entirely unseen to most people. Basically, there's 200 code, which is OK success. This is almost never seen unless you're looking at the source material, and basically says, yay, it worked. Here's your page. The permanent is a redirect page, the 301 code, which will send you from A to B. And it sends everybody over there. It sends everything over there. It's a complete redirect. Sorry, the page doesn't exist anymore. Here's another page that you were redirected to. The temporary 302 will send A to B as well, but it doesn't send any links. Therefore, you're not able to actually flow between the pages back and forth to each other as you would otherwise. Error 404 not found. Everyone has very fond experiences with this thing. Basically, any one that begins with a 4 means something went wrong. And error 404 is no exception. The page is gone. Hello, there's nothing left. Goodbye, it doesn't exist. Then there's 500. This is a server error. There is no page. Nothing has happened. Nothing gets sent. No one knows what they're doing. As the title says, everyone is lost and confused. And error 503, unavailable. It's another way to say FR4 really, but basically, it works out that way. These are the 400 and 404s and others. These are the typical problems that HTTP will have. If anything goes wrong, you're expecting to see something like this, like a bad request is 400, 404 is not found, 405 method not allowed. All of these represent various different reasons that an HTTP won't work. Basically, communication problems, anything of the like, is represented. And finally, a final note about the internet. The World Wide Web is not the internet. The internet is anything that runs on TCP/IP protocols. The World Wide Web is a portion of the internet that runs on HTTP and HTTPS, with the S representing secure and, in general, creates encryption and safety. Emails, FTPs, BitTorrents, VoIPs, and IRCs also represent portions of the internet. These are my references for this particular PowerPoint.
Well, that's all I've got to say for now. So, until next time, bye.